Millions of people have had to go through surgical implant, such as orthopedic implant due to joint replacement. This is usually due to aging effect, and also some also have to occur due to injury and from real life or occupational strain. What we have seen is in the United States, 1.8 million people have had to go through orthopedic implants annually. 1.8 million people. This is expected to surge to 3 million by 2040. Guess what? The US global market of orthopedic implants currently is about $25 billion. And the United States has 50% of this orthopedic implant, 50%. But what usually happens is the fact that when this patient go through orthopedic implant, plant this thing in their body, there is always a need to go through a revision surgery, thereby having early open surgery. Why is this happening? There is always issues with the mismatch between the elastic modulus of the bone and the elastic modulus of the commercial materials that is being used. Commercial materials like titanium, aluminum, for vanadium has an elastic modulus of 110 gigapascal. And your bone, the bone in your body, the bone in my body, has an elastic modulus of 20 gigapascal. There is a mismatch. This is where my research is coming in. With additive manufacturing, we can strategically tailor the composition by adding a better phase stabilizing element into this already existing commercial alloy. And then we have been able to achieve from 110 gigapascal, we've been able to achieve 55 gigapascal, relatively close to that of the bone. And this patient doesn't have to go back into the surgical room for a new open surgery. And then with this research, this has opened a new pathway for designing functionally graded materials tailored towards specific application like biomedical implant. Thank you.